Hi dear students, welcome to the part 2 video for the chapter alcohol, phenols and ether. So here we are going to discuss the other 50 important MCQ for the same chapter. Okay, so let's start from the new question. Here we have the question. How many alcohols with a molecular formula C4H10O are chiral in nature? You know what is the meaning of chirality or asymmetric carbon, correct? What is the formula given? C4H10O. Let me draw the maximum possible structures of the same formula. Okay. It's an alcohol, right? So there are total 4 carbon atom with one alcohol. Or I can place the position of alcohol on the second carbon atom. Or I can make a branch on carbon and one alcohol atom. And all 3 carbon atom and 1 alcohol, right? These are the maximum possible isomers of the formula C4H10O. Alright, let's see. Let me just correct the valency also. CH3, CH2, CH2, CH2OH. Here 2H, 3, CH3, CH3, CH, CH2. Here CH3, CH3, CH3. Alright. Can you identify, dear student, in these 4 alcohol, how many alcohols which contain chiral carbon atom? You know, chiral carbon means the carbon, all the 4 valencies are satisfied by 4 different groups. Correct? I think this one doesn't contain a chiral carbon. I think this carbon, if you consider it having same methyl group, so no. And this carbon, if you consider all are same groups, so no. I think only possible is one compound. Correct? Why? If you consider this carbon, it is connected to one methyl group, one hydrogen, one OH, one ethyl. All are different group. That is the only chiral carbon containing one. So how many alcohol with this formula is chiral? That's only one compound. Second question. CH3, CH2OH. Here all this is a primary alcohol, right? This is a primary alcohol. If you want to convert into aldehyde, we know we studied in the part 1, which is the best reagent. That is what? Pyridinium chlorochromate, PCC, right? Pyridinium chlorochromate is the best reagent. Next question. The process of converting alkyl halide into alcohol involved. If you consider a alkyl halide RX, this process of converting into alcohol is known as what? What's the reaction? You know how you can convert a haloalkane into alcohol? By treating with which one? Aqueous KOH. What is happening here? This halogen that you are leaving, OH minus nucleophile, you are substituting. So this is called what? Nucleophilic substitution reaction or substitution reaction. Correct? Next. Which of the following compound is aromatic alcohol? Most of the students are studying that benzene containing all compounds are aromatic. Not like that. In the case of phenol, let me tell you. Please note this point. Phenol and phenol derivative. Phenol and phenol derivatives means they derived from phenol. Phenol and phenol derivatives are not aromatic. Okay, keep in mind. Phenol and their derivatives are not aromatic. So compound A is not aromatic. Compound B is not aromatic because both of them contain alcohol. But compound B and C contain benzyl group. Yes or no? You know what is benzyl group? Benzene with the CH2, right? Benzyl. Benzyl alcohol and their derivatives are which one? Aromatic in nature. Option B, or compound B and C are aromatic. So which of the following aromatic is option A? So keep in mind all of you, phenol and their phenol derivatives they are not aromatic compound. Okay. Next, you know phenol is said to be carbolic acid, right? Give what is the IUPAC name of the given compound. Total, first as per the IUPAC name, select the longest chain. No doubt, this is the longest chain which contain maximum carbon. 1, 2, 3, 4, 5, 6. What all groups are there? Alcohol is there, chlorine is there. Which is the major functional group? Alcohol. So let's put number 1. Okay, 1, 2, 3, 4, 5, 6. What's the name, dear all? Fifth position there is a chlorine. Total 6 carbon atom. Hexane. Second position there is a alcohol. So we can say 5 chloro, hexane, 2 ol. Option B can be the answer. Correct? Second one is the answer. What is the IUPAC name of metacresol? We discussed what is meant by cresol. Cresol means benzene, phenol which contains CH3. Metacresol means position is on meta position. You know which is the major group here? Major group is phenol, right? And alcohol is the major group number 1, number 2, number 3. 3-methyl phenol. That's a compound, right? 3, third position methyl. 3-methyl phenol, not 3-methoxy, 3-methyl phenol is the compound. IUPAC name of the given compound. This given compound is an ether, dear all. CH3CH, CH3, OCH3. How to name ether? Simple. You see where is the oxygen here? Left side there are 3 carbon atom, right side there are 1 carbon atom. So make first of all the selection of longest chain. Parent chain. Where is your parent chain? Of course, left side, because there is a maximum number of carbon. Among that, you take the longest chain. Which is the longest chain? I can take it here. This is the longest chain, right? Longest chain. If it is the longest chain, remaining all groups you can take it as a branch, which means this is a branch. What is this branch is called? Methyl group with oxy is called methoxy. Correct? So on oxygen atom, left and right side, which is the maximum carbon atom, that part you select it as the longest chain. Among that you say take the parent chain. Okay, this is propane is the parent chain. So let me number the carbon number 1, 2, 3. Second position there is a methoxy group. Therefore 2-methoxy, 2-methoxy, total 3 carbon atom in the parent chain. 2-methoxy propane. 2-methoxy propane. What is the answer? Option B, 2-methoxy propane. Okay, next. Which of the following compound will react with the sodium hydroxide solution in water? The same one type question we discussed in part 1 video. Which will react highly with the sodium compound? You know, which is highly reacting with the sodium mean they indirectly asking you which is highly acidic in nature. Once again, which is highly acidic in nature. What is the compound number 1, dear all? It's given here. Benzyl alcohol. Compound number 2 is given tert-butyl alcohol. Right, tert-butyl alcohol. Compound 3 is given ethanol, just normal ethanol. What is compound 4th one? 4th one is phenol. Which is more acidic in nature, dear all? You know, aliphatic alcohols are lesser acidic than aromatic. Sorry, like not phenol. Phenol is not an aromatic one. A benzene containing one. So aliphatic alcohol, option number 2 and 3 we can cut it, because you know aliphatic alcohol containing electron donating group. We know electron donating groups, they will decrease the acidity, correct? But benzyl alcohol and phenol, which one? You know, benzyl alcohol, if it lose this hydrogen, you will get this anion. You see the oxygen atom is not directly connected to benzene ring, it cannot make any resonance, it is not stable, so they are not most acidic. But in phenol, you know very well, if it lose this hydrogen, it is forming phenoxide ion, you know, it is highly stable due to resonance. So phenol is highly acidic among this one. So which compound will react with the sodium faster mean, which is highly acidic in nature? That is 4th one, phenol is the answer. Now, phenol is less acidic than which of the compound? Okay, first one is given orthomethoxyphenol. Orthomethoxyphenol. Compound number 2, ethanol, CH3CH2OH. Compound number 3 is orthomethylphenol. And compound number D or the 4th one is orthonitrophenol. Ortho, right? Sorry. Not in para, ortho position, there is a nitro. Alright. See all of you. In the first compound, OCH3 is present. OCH3, alkoxy group. In part 1 video, I given which are electron withdrawing and donating. Simply see that. Alkoxy groups are electron donating group. Alkyl groups are electron donating group. Ethanol you don't need to consider here because aliphatic alcohols are less acidic compared to phenol. And nitro group is a electron withdrawing group. We studied that electron withdrawing group, they can increase the acidity. Electron withdrawing group, they can increase the acidity. So which one is the answer, dear student? Phenol is less acidic than, so which is the most acidic in this option? That is which one? Orthonitrophenol. Orthonitrophenol is the most acidic one. Phenol will be less acidic than orthonitrophenol. Next one. Which of the following is most acidic? Compound number is given cyclohexanol. Cyclohexanol. Compound number 2 is phenol is there. Okay, phenol is there. Compound number 3 is metachlorophenol. Metachlorophenol. And compound number D is benzyl alcohol. What's that? Benzyl alcohol. Which one do you know? Which one can be the answer? Cyclohexanol is a normal aliphatic type of cyclic one, no, because benzyl also we can cut it. Phenol is there because phenol, if it lose this hydrogen, it forming more stable ion, right? So which one? Of compound number 2 contain pure phenol, compound 3 contain chlorine. We studied that if chlorine alone present in benzene ring, it acts as a which one? Electron with the electron donating group. Sorry, electron donating group. But here the major group is which one? Phenol on which chlorine? Here chlorine, the power is as an electron withdrawing group. Chlorine acts as a electron withdrawing group. If there is an electron withdrawing group, what happened to the acidity? It increases. So metachlorophenol is most acidic in this compounds. Mark the correct order in the decreasing order of acid strength. Okay, let's go. First one is phenol, second one is para-nitrophenol. Nitro group is an electron withdrawing group, methoxy group is an electron donating group, nitro group is an electron withdrawing group, methoxy group is an electron donating group. Dear student, let me tell you a data here. We know what is this compound? Phenol. Okay, phenol. If you consider phenol in which nitro group ortho, nitro group meta, nitro group para. What is the first compound? Ortho nitrophenol, meta nitrophenol, para nitrophenol. Please keep in mind what is the acidity order of these nitrophenol. Please keep in mind POM. The order is what? POM. 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 Para having greater than oxygen than meta. POM. That is the order we have to follow. Okay, for acidity. Even for melting point also, this is the same order. Okay, let's go. So, when you consider definitely B and D having greatest acidity because they contain electron withdrawing group. Among B and D, B is para, D is meta. Which one having greater? Para. It's an experimental one. So B is greater, right? B greater, that's only one option is given. Option number 2. B after that, D. Alright? Fine. Next. Phenol can be distinguished from ethanol by the reaction with. Dear all, phenol you can distinguish from other compound mainly by 2 methods. Let me tell you. First method is said to be neutral ferric chloride. Neutral ferric chloride test. Second one is known as bromine water test. Bromine water test. Okay. You can distinguish ethanol can be distinguished from phenol. Phenol majority phenol is given only the 2 tests, neutral ferric chloride and bromine water test. Let me tell you, when phenol treated with neutral FeCl3 ferric chloride, it will give you a complex of iron and phenoxide ion. Just remember the name, it's having a violet color. If you are getting a violet colored complex with the neutral ferric chloride, you can confirm that yes, the compound contains phenol. Bromine water test already we discussed in bromination. When you treat phenol with the bromine water, with the Br2 water, we studied that it will give you all the ortho and para positions are occupied by bromine. 2,4,6 tribromophenol. As I told you, this is having a white color. So these are the major pests we are using to distinguish from phenol from other compound. So bromine water, neutral ferrichloride. That is the maximum one. Sodium we can use it but not fully because both are acidic in nature. Phenol is acidic in nature, ethanol also acidic in nature. The hydrogen transfer can be positive. Phenol on distillation with the zinc dust give. We studied this reaction here all. Phenol, benzene with the OH. When you treat it with the zinc, we know zinc is a reducing agent. It will take this oxygen and zinc oxide eliminated. We are getting benzene. Right? So phenol on distillation with the zinc dust give benzene, compound number C. Option number C is the correct answer. Reaction of an alcohol with the organic acid is called. What is an acid for alcohol? Let me take for example CH3CH2OH, ethanol. Alcohol treating with organic acid. Organic acid is which one? Methanoic acid, ethanoic acid, those things. Let me take CH3COOH. Here all, when an alcohol treated with an acid, what will happen? They will undergo dehydration. Yes or no? They can eliminate water. What eliminate water? You club it CH3, CH2O, CO, CH3. What is this? Ester. Ester formation is called esterification. Yes or no? Alcohol when react with acid, you will get dehydration by forming esterification. So what is the process called? Option A, esterification process. The increasing order of acidic strength of the following is. What is the acidic? So many questions we are discussing acidity. Maximum important question. All of them contain phenol. So we have to check at the present group whether it is electron withdrawing or donating. Nitro group we know, electron withdrawing group. Methyl group you know, electron donating group. Methoxy group you know, electron donating group. So confusion. There is no confusion which one having major acidity, because electron withdrawing group, if it is there, its acidity increases. So which one having greatest one? First one, no doubt. But first one containing two options are there, option A or B. Here all. Next confusion we have to clear it. Compound number 2 and compound number 3, both of them contain electron donating group. Which is the strongest electron donating? Keep in mind all of you. Alkoxy groups are strongest electron donating group than alkyl groups. Okay, alkoxy, because oxygen is there now. Oxygen contains electron pair, so that will give more electron. That is the best donating group. So compound number 2 and compound number 3, when you consider compound number 3 having very least acidity, because that is the strongest donating group. So we can say first one having greater, then 2, then 3. Okay, third one having option B should be the one. First one contain electron withdrawing group, so more acidity. Third one, the donating group is a very stronger donating group, so acidity very less. Third one. Next, in alcohol, an increase of branching in carbon chain result in boiling point. Whatever the system, branching increases, boiling point decreases. So, as the number of branching increases, increase in branching, what happens to boiling point? We can say decreases. Alkene react with the water in the presence of acid as catalyst to form alcohol. You studied now? The first preparation of alcohol. If you consider a alkene, for example, propene, if you are adding water in presence of an acid, this is called acid hydrolysis, acid catalyzed hydrolysis. Here actually we are doing a free radical, the Markovnikov addition. Water contain H plus and OH minus. Negative will goes here, H plus will goes here. You will get CH3, CHOH and CH3. This is what you are going to get. Yes or no? Alright. Now, you studied the mechanism for this reaction. You can check the textbook. The first preparation of alcohol from alkene by acid catalyzed hydration. There are 3 steps and 3 names for each step. Let me remind you, step number 1 is known as protonation. Step number 1 is known as what? protonation. In first step, you can observe the alkene taking a proton, H plus ion. That is called protonation. Step number 2 is nothing but then water will attack. Water is a nucleophile. So let's call nucleophilic attack, and they will form carbocation and form carbocation. This is you can observe in the second step. In the last step, nothing but the removal of the proton. That is called removal of proton is said to be deprotonation. You can check with the textbook, okay? Textbook, first preparation, deprotonation. These are the steps actually happening during this reaction. So come to the question. Alkene react with the water in the presence of an acid as catalyst, it form alcohol. Yes, it form alcohol. Option A, nucleophilic attack of water on carbocation. Yes. Protonation of alkene and the protonation is the deprotonation. All of the steps you can observe. Option D. All of the options or all of the steps you can observe during the reaction in step 1, step 2, step 3. Now, Lucas test is associated with, Lucas test is a test to distinguish between primary, secondary, tertiary alcohol. Lucas test is associated with which one? Alcohol. It is not applicable to phenol, okay? Only aliphatic alcohol. Williamson synthesis is used for the preparation of Williamson synthesis, Williamson ether synthesis. Lucas reagent is a mixture of concentrated HCl with anhydrous zinc chloride. HCl and zinc chloride. Option D. Arrange the following compound in the increasing order of their acidic strength. Again, what is the first compound? Propan 1-ol. What is the second compound? 2,4,6 trinitrophenol. 2,4,6 trinitrophenol. That is our picric acid, the yellow colored one. This is number 1. Number 2. What is number 3, dear all? 3-nitrophenol. Okay, 3-nitrophenol. Okay. Fourth one is what? 3,5-dinitrophenol. Okay. 3,5-dinitrophenol. What is the fifth compound? Just phenol. Okay, phenol, just phenol. So many compounds are there, right? No problem. Okay, 4-methyl-phenol. What is the last one? 4-methyl-phenol. Okay, let's go. Here all, in the first compound, when you consider the first compound with all other, first compound having the least acidity, no doubt, because it is an aliphatic alcohol. All other containing phenol. Phenol is more acidic, The next factor, electron withdrawing or electron donating group. In the second compound, so I can say first compound having least one, okay? Then, this contain 3 electron withdrawing group. It contain 1 electron withdrawing group at a meta. It contains 2 electron withdrawing group, and it is pure phenol, and CH3 is an electron donating group. So let's go to the answer, dear all. Let me start from the highest acidic one. Which is your highest acidic compound? I hope your answer is the compound number 2, because electron withdrawing group will increase the acidity as the number of electron withdrawing group increases, again strength of acid increases. Second compound contains 3 nitro group, so second compound having greater acidity. After that, okay, second one over. After that I can go to fourth one because they contain 2 nitro group. Fourth one. After that, I can go to third one because it contains 1 nitro group. After that, I think fifth one or sixth one. Fifth one, because sixth one contains electron donating group. It will reduce the acidity of phenol. So we can go to fifth one and then sixth one, and least is first one. Okay, what's your answer? 2,4,6 trinitrophenol, dinitrophenol, 3-nitrophenol, and the propan 1-ol. No. Propan 1-ol should be the least one. Propan 1-ol is the R. That's it. Question is increasing order. No, that's it to answer. Propan 1-ol, that is the least one. So 2,4,6 trinitro greater, then dinitro, then nitro, then phenol, then methyl. Yeah, option D is the answer. So major factor affecting acidity, you have to check it that if they given a normal aliphatic alcohol like methanol, ethanol, propanol and phenol, aliphatic alcohol having least acidity. Then among phenol, if they given withdrawing or donating group, careful, electron withdrawing group increase the acidity, electron donating group decrease the acidity. Okay, keep in mind, it's a very important question, acidity order. Next question, all of you. With the dilute nitric acid at a low temperature, phenol yield. We already discussed in part 1 what are the two type of nitration possible. With the dilute nitric acid at a low temperature, phenol. When we treat phenol with the dilute nitric acid, dilute HNO3, it will give you two nitro products, orthonitrophenol and you will get para-nitrophenol, right? Orthonitrophenol and para-nitrophenol. If you are treating with a concentrated nitric acid, what is the situation? You will get 2,4,6 trinitrophenol picric acid. Yes or no? Yeah. Next one. The reaction of C2H5ONA with the C2H5I. What is this? This is a alkyl iodide or halide. What is this? Sodium ethoxide. Sodium ethoxide. You are getting a ether. What is this? A haloalkane reacting with the sodium alkoxide. You are getting ether is called what? Williamson synthesis. Williamson is the only one to prepare ether. 3-pentanol is an example of what is 3-pentanol? Let me draw the shade. This is pentan. Third position alcohol. 3-pentanol. So let me take CH3, CH2, CH2, CH3. Alright? We can have this one. So in this case you can observe how to identify the alcohol in which the alcohol connected carbon is directly connected to 2 carbon. Therefore, it belongs to a secondary alcohol. The alcohol connected carbon directly connected to how many? If it is 1, primary. If it is 2, secondary. Right. Ketones are reduced to the corresponding alcohol by catalytic hydrogenation to form. Primary alcohol on oxidation, we will get aldehyde. Secondary alcohol on oxidation, we will get ketone. Yes or no? So here the question, ketone on reduction, what you will get? Ketone on reduction, you will get secondary alcohol. So where is the answer? Option D. Ketone on reduction, you will get secondary alcohol. What is the starting material for picric acid? How we are preparing picric acid, dear student? From phenol. Question is, what is the starting material? Okay, what is picric acid? That's not the question. This is phenol. Phenol when treated with which one? Concentrated nitric acid. Phenol is a ortho-para directing group. All the ortho and para positions are occupied by nitro group. This compound is said to be the yellow colored picric acid. So, what is the starting material means? Phenol is the starting material to prepare picric acid. Among the following set of reactant, which one produces anisole? What is anisole, dear all? Benzene with the OCH3. Benzene with the OCH3. Option A, can we use it? No, right? Because it doesn't contain a benzene ring, phenyl ring. We cannot use it. Option 2 is possible. Let me try. What is option 2? That's given phenol. Okay, option 2, let me check it. Phenol is given. Phenol treating with which one? NaOH. Okay, phenol, let me treat with the NaOH. What will happen? This hydrogen and OH eliminated as water. You will get benzene with the ONA, sodium phenoxide. Then we can treat it with which one? Methyl iodide. Okay, what will happen? Sodium iodine will eliminated as sodium iodide. Yes, we can prepare anisole OCH3. Let's go with option number 2. You can check with the other thing, you won't get it. Okay, option 2, you can prepare anisole. First treating phenol with the aqueous NaOH, you are getting sodium phenoxide. Then treated with the methyl iodide, sodium iodide eliminate, methyl will substitute. Identify Z in the sequence of reaction. What is the starting material? CH3, CH2, CH double bond CH2. Okay, what is this? But1-ene. They are treating with the HBr in presence of hydrogen peroxide. Addition of a positive and negative species. H plus a negative part to in presence of peroxide anti-Markovnikov rule. Negative part will goes to carbon with a more number, hydrogen to less number. So we will get CH3, CH2, 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 Br, 1-bromobutane. This compound treated with which one? C2H5ONa, sodium ethoxide. Sodium ethoxide. When a haloalkane treated with the sodium alkoxide, what will happen dear all? Bromine and sodium eliminated, you will get ether. CH3, CH2, 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 O, C2H5 is the product. Any answer is matching? CH3, CH2 thrice, OCH2. Option A, right? Option A, right? CH3, okay, CH3. CH2 thrice, CH2 thrice, yeah. Then O, then CH2, CH3. Correct. Option A is the final product. What is the decreasing order of boiling point of primary, secondary, tertiary alcohol is? You know, a primary alcohol, for example, let me take an isomer. For example, 1, 2, 3, 4. Okay, this is one alcohol. Let me take, this is one of the alcohol. This is one of the alcohol. You see, I think the first alcohol is a primary alcohol, correct? Because that alcohol connected carbon only connected to one carbon. If it is so, this is secondary, this is tertiary. What do you think? Which one having greatest boiling point? Boiling point mainly depends on mass. Okay, all of them having same mass. The next factor, branching. Branching increases, boiling point decreases. Which one having so much branching dear all? Primary no branching, right? Higher boiling point. So primary greater than, secondary greater than, tertiary least, because tertiary contains so many branches. So what is the order? What is the decreasing order of boiling point? We can go with option A. Now, which one of the following on oxidation gives a ketone? We know that, again I am repeating, primary alcohol on oxidation, we will get which one? Aldehyde. Secondary alcohol on oxidation, we will get which one? Ketone. So the question, which one of the following on oxidation gives a ketone? They are asking you, which is a secondary alcohol? Simple. Yeah, I think here no need to discuss that. Directly they given. They didn't mention any compound also. What is that? Secondary alcohol. You know, primary alcohol on oxidation will get you aldehyde. Tertiary alcohol won't undergo oxidation. Instead of that, dehydration. Part 1 we discussed. Right. Which of the following sequence the product is seen? Identify the end product. Let's go. Starting material is CH3CHO. It is treating with a reducing agent, hydrogen in presence of palladium. You know, aldehyde on reduction, we will get primary alcohol. Ethanol on reduction, you will get you ethanol. Okay, this is your compound A. This compound A, when react with the sodium, you know, alcohols are acidic in nature, so this hydrogen is replaced by the sodium. We will get CH3CH2ONa, sodium ethoxide. This is your compound B. It is treating with which compound? CH3I. What will happen? If you treated with the CH3I, this NaI will eliminate. You will get CH3, CH2, CH3, Williamson synthesis. What is your product? Your product is a ether. Yes or no? When a sodium alkoxide treated with the alkyl iodide or haloalkane, we will get ether, Williamson synthesis. What is the product formed in the following reaction? This question we discussed in part 1 video, C6H5OCH3. What is this? Anisole, methoxybenzene. When we treated with the hydrogen iodide and heating, we want to know which bond we have to break it. Either you can break this carbon-oxygen bond or you can break this carbon-oxygen bond. As I told you, in the aromatic ether, H plus is there, I minus is there. So which ion you can make it in the anisole? Which CO bond you can break it? Dear student, if they given an aromatic type of ether, after the breaking the bond, you should get phenoxide ion. After breaking the bond, you should get this ion. If you want to get this ion, which bond you have to break it? The down one or the right one? Of course, the right one. Then you will get phenoxide ion, CH3+. Then double displacement. What we have to do here, to the phenoxide O minus, H will attack. With the CH3, I will attack. So what is the product? C6H5OH and the CH3I, that is option A is the product. Butan 2-ol is a, I think this question we discussed, right? It's a repetition, okay? Butan 2-ol. Butan 2-ol, the OH connected carbon directly connected to 2 carbon, therefore it is a secondary alcohol, previous year, secondary alcohol. Primary alcohol can be obtained from the reaction of RMGX. What is RMGX? Grignard reagent, right? Grignard reagent. In the first video, we clearly mentioned that any Grignard reagent, when you treat it with the formaldehyde or methanol, you will get always primary alcohol. In any Grignard reagent, when you treat it with the methanol or formaldehyde, always you will get your primary alcohol. So primary alcohol you can prepare from Grignard reagent, treating with which one? HCHO, methanol, option A. Ethyl propanoate on reduction with the lithium aluminum hydride yield. One of the questions we discussed in part 1 video. Ethyl propanoate. I think in part 1 video we discussed ethyl acetate. What is the group ethyl CH3 CH2? What is meant by propanoate? What is propanoic acid, dear student? CH3 CH2 COOH. If it lose this hydrogen, remaining species is called propanoate ion. So let me take it the opposite one because it is an ester. CH3 CH2 COO. This is the one. This is the ester, okay? Got the idea how to write the ester? This is ethyl propanoate. This is we are going to reduce with the lithium aluminum hydride. I told you in the first video, part one video for the same chapter, ester on reduction, you will get 2 alcohol. Simple to write, break this CO bond. Left side, how many carbon atom? 2 carbon atom. 2 carbon containing alcohol, which one? CH3, CH2, OH. Right side, how many carbon atom? 3 carbon. What is the 3 carbon containing alcohol? CH3, CH2, CH2, OH. So the product is ethanol and propanol. Ethanol and propanol. Option second is the correct answer. Okay. Ester on reduction, 2 alcohol. The most acidic alcohol among the following. First one is given methanol, CH3OH. Second one is given ethanol, CH3CH2OH. Third one is given isopropyl alcohol. You know isopropyl group. This is the isopropyl alcohol. And fourth one is tert-butyl alcohol. Okay, tert-butyl alcohol. All are aliphatic alcohol. Fine. What is the major factor affecting acidity? We studied in many questions. Electron withdrawing group, if it is there, it will increase the acidity. Electron donating group, if it is there, it will decrease the acidity. Correct? Yes or no? Here all fully alkyl groups only, right? Here there is a methyl group. Here there is a methyl. The alkyl groups are there. Methyl groups are there. Methyl groups are there. You know, all are electron donating group. You know, electron donating group, if increases, acidity decreases. So where you can identify less number of electron donating group, that is in first option, methanol. Just a methyl group is there. All others contain maximum carbon and hydrogen. All methyl groups will do. Maximum methyl group means acidity decreases. Next one. Consider the following reaction and identify the product. I think this question we discussed in part 1 video. Hope you remember that. Phenol when treated with zinc, you know, it will give you benzene reduction. Benzene when treated with a methyl chloride in presence of anhydrous AlCl3, it will follow Friedel-Crafts alkylation. You will get toluene. You know, toluene treated with alkaline KMnO4. You know, alkaline KMnO4 is the strongest oxidizing agent. It will convert the alkyl group directly into carboxylic acid. So your final product is which one? Benzoic acid. Okay, benzoic acid. Option third. What is the product in the following reaction? What is the starting material? Ethanol, CH3CH2OH. It is treating with which one, dear student? Phosphorus with the iodine. It is a iodine, alcohol is substituted by which one? Iodine. Phosphorus with the chlorine, PCl3, chlorine will substitute. Phosphorus with iodine, iodine will substitute. You will get iodoethane, CH3CH2 iodine. It is treating with which one? Magnesium. It is treating with the magnesium in presence of dry ether. When a haloalkane treated with the magnesium, you will get Grignard reagent. What you have to do, just to add the magnesium in between the carbon and iodine. We will get CH3, CH2, MgI, ethyl magnesium iodide. This one we are treating with which one, dear all? Formaldehyde. What is formaldehyde? HCHO. And after that, hydrolysis. We studied in the part 1 video how to write the product directly when a Grignard reagent treated with the aldehyde or ketone. Magnesium positive, so these alkyl groups all are negative charge. What you have to do, this negative charge alkyl group directly go and attack to this carbon atom. Yes or no? Okay, let me just rewrite this one. Whatever the alkyl group, they will directly go. They will directly go to the carbon atom, and this O becomes O minus. So what I can write, I have HCH. Here what is attacking? CH2, CH3 attacking. The O becomes O minus. To this O minus, what will attack? This Mg plus I will attack. Yes or no? Finally, what is happening? Hydrolysis. We are adding water. Water containing H plus and OH minus. So H plus ion goes to this O minus part, OH minus goes to Mg plus part. So what is the major product? We have CH3, CH2, CH2, OH. Right? This will be the product. What is that? Propanol. Option 4. And even though you can identify the product, because we studied any Grignard reagent, when you treat it with the formaldehyde or methanol, your product is a primary alcohol. Correct? Primary alcohol. So next, definitely it is not aldehyde. Either it can be butanol or propanol. How we can identify? Because in this, your Grignard reagent contain 1, 2 carbon atom. Your aldehyde contain 1 carbon. Total 3. 3 carbon containing alcohol. Which one? Propanol or propanol. The compound that react fastest with the Lucas reagent. Lucas reagent is very higher reactivity, is given by tertiary alcohol, right? Which is a tertiary alcohol? Let's find out. Butan 1-ol, you can identify it is a primary alcohol. Butan 2-ol, it is a secondary alcohol. Let me check with the third one. What is the third one? 2-methyl. 2-methyl propan 1-ol. Is it primary, secondary or tertiary, dear? OH connected carbon, only connected to 1 carbon, it's primary. So that also not your answer. What about this? 2-methyl propan 2-ol. 2-methyl propan 2-ol. Yes. Here the alcohol connected carbon directly connected to 3 carbon. This is the tertiary one. Tertiary will react with the Lucas reagent faster. It will give you immediate turbidity. Next. What is given here? Alcohol is aldehyde is given. Aldehyde is treating with which one? Hydrogen reduction. Aldehyde on reduction, you will get a primary alcohol. Okay, fine. Question: the catalyst used in the above reaction, hydrogenation or the addition of hydrogen, we can carry out in presence of nickel, platinum, palladium, all of the catalysts. All of the above are possible. Methyl alcohol on oxidation with what is methyl alcohol? CH3OH. Methyl alcohol on oxidation with the K2Cr2O7. Potassium dichromate and the KMnO4 potassium permanganate are very strong oxidizing agent. They will convert alcohol directly into carboxylic acid. What is the 1 carbon containing acid? That is HCOOH, methanoic acid. Because what is the starting material? Methanol. It will give you methanoic acid. So what is the answer? Compound number 3, HCOOH, formic acid or methanoic acid. Which of the following again most acidic? What is paracresol? Paracresol, cresol mean benzene, phenol with a CH3, paracresol compound number 1, and compound number 2 is parachlorophenol, right? Parachlorophenol, and third one is paranitrophenol, okay, and then fourth one is which one? Para-aminophenol. Amino means which group? NH2 group. Correct. Let's go here. Here, all of them contain phenol. Phenol is highly acidic, so there's only one factor, electron withdrawing or electron donating group, which is present. Here, alkyl groups are electron donating group. Chlorine, if it is alone on benzene ring, it acts as a donating group, but here not alone, phenol is also there, then acts as an electron withdrawing group. Nitro group, it is a very strong electron withdrawing group. And amine groups are which one? It is an electron donating group. Why? Because nitrogen contains lone pair, it can donating group. Which is the most acidic? We know that. Any question we discuss, electron withdrawing group, if it is there, acidity increases. So here electron withdrawing group is second and third compound. Strong electron withdrawing group is there. Of course, paranitrophenol is the most acidic one. Dehydrogenation of 2-butanol. What is 2-butanol? CH3CHOH, CH2CH3. Dehydrogenation means what? Elimination of water. 2-butanol gives. What it can give? Dehydrogenation. Dehydration actually, right? Dehydration, elimination of water. Water how to eliminate? Alcohol you should eliminate from alpha carbon. One hydrogen you have to take from beta carbon. So unfortunately there are two beta. Let me take this is beta 1, this is beta 2. You can take one hydrogen from beta 1, so you have to make the double bond between those alpha and beta. So I think your product will be but1ene, right? But1ene. If you are taking, this is beta 1 when you are taking hydrogen. If you are taking hydrogen from beta 2, you have to make double bond between those alpha and beta. So what is the product? But2ene. What is that? But2ene. So this is but1ene, this is but2ene. Which is the major product? Both answers are there. Which is the major product? But2ene. According to Seitz's rule, more substituted alkenes are more stable. Maximum try to make the double bond in the more crowded area at the center. It will be the stable one. Okay, so but2ene is the major product. The compound having lowest boiling point among the following is, they given phenol. Okay, phenol is given, orthonitrophenol, metanitrophenol, and we have paranitrophenol. Okay, the compound having lowest boiling point among the following is, this student in phenol system, especially in orthonitro, metanitro, paranitrophenol, we discussed a speciality. I will give you the entire order. When you consider the nitrophenol and the phenol, the nitrophenol part having the lowest boiling point, among this nitrophenol, which one having lowest? Melting point order and boiling point order, let me give you. In orthonitro, metanitro, paranitrophenol, what is the correct order of melting point? Keep in mind, POM. What is that? Para greater, ortho greater, meta. POM. In boiling point, when you discuss the first two, you interchange it. Ortho greater than, para greater than, meta. This is the order. So the compound having lowest boiling point is for which one? Ortho. Okay, ortho. And even orthonitrophenol. Another reason. Orthonitrophenol, it is connected through which bond? Very weak intramolecular hydrogen bonding. Intramolecular hydrogen bonding is the weakest bond. It can volatile faster, vaporize faster. It's having lowest boiling point. Next one, the ionization constant of phenol is higher than that of ethanol. You know, alcohols are acidic in nature. For acidic nature, which is the ionization constant we are using? Ka value. We studied no Ka and Kb. Ka value is called ionization constant of an acid. We studied that Ka value increases, we can say that acidity also increases. Ka value increases, acidity increases. pKa value increases, acidity decreases. You know that. So they are saying that what is the two species given here? Phenol. Okay, phenol and ethanol. Phenol and ethanol. Alright. You know very well which is highly acidic in nature. Which is that phenol is highly acidic in nature. So their Ka value will be greater, no? Yes, Ka value will be greater. Its Ka value will be lesser. So what is the answer? Ka value of phenol is higher than ethanol. Why? Phenoxide ion is bulkier than ethoxide. Phenoxide ion is stronger base than ethoxide. Phenoxide ion is stabilized through delocalization. That's a correct one here. You know, why phenol? Why phenol is more acidic? You know, phenol, when it loses this hydrogen, you are going to get a phenoxide ion. Phenoxide ion. This oxygen contain lone pair, so it can undergo resonance stabilization. So phenol is ready. Okay, phenol is asking anyone please take the hydrogen from me. So after donating that hydrogen, the forming phenoxide ion is a highly stable one. It's a highly stable one due to resonance. So that resonance is also known as what? Delocalization of pi electron. Option C is the correct answer. Which one among the following is called the Williamson synthesis? You know, Williamson synthesis, the final product is an ether. Yes or no? A haloalkane treating with the sodium alkoxide, we are getting ether. Option A is possible. Option A, final product is a hydrocarbon. No. Option B is a enol, alkene with aldehyde. No. Option third one is possible. No. Option third one you can see alkyl iodide treating with the sodium alkoxide, we are getting ether. Yes. This is what? Not ether. Right? Option third one is the Williamson synthesis. An organic compound A reacting with the PCl3. A organic compound A reacting with the PCl3 is giving compound B. The compound B with the sodium metal atom is in the presence of dry ether. In the presence of dry ether. I think it is the dry ether and gives normal butane. Yeah, it is what? Williamson synthesis, right? Sorry, the Woods reaction. Sorry, Woods reaction. This A and B are very simple. Here on. You're starting it, let me make a back calculation. What is your final compound? Butane. Okay, butane. If you want to get butane through sodium in presence of dry ether, mean Woods reaction. So if you want to get butane, what should be on left side? It should be CH3, CH2, Cl. Because PCl3 we are using. You know, two molecules of ethyl chloride will combine with the sodium in dry ether. You will get ethyl plus together butane. If you want to get ethyl chloride by using PCl3, I should have ethanol as a starting material because alcohol we can convert it into chlorine by using PCl3, PCl5, thionyl chloride, etc. So what is the answer? A compound is ethanol and A compound is ethanol. B compound is ethyl chloride. Yes? Question is A and B, right? Okay, ethyl chloride and ethanol. Then, the compound that generate methyl-ethyl ketone upon oxidation. What is the meaning of methyl-ethyl ketone? Very simple, okay? That's nothing but butane 2-on. Means, this is methyl, okay? Methyl-ethyl. What is ethyl? CH3, CH2. Okay? Methyl-ethyl. There is a ketone. This is the meaning. Butane 2-on is also called what? Methyl-ethyl ketone. I want to get this ketone. The compound that generate this ketone upon the oxidation. You know, ketone you are getting by the oxidation of secondary alcohol, right? Secondary alcohol on oxidation, we will get ketone. Which is a secondary alcohol? 2-propanol. 2-propanol is there, 2-butanol is there. Anyway, we can cancel 1 and 4 because second one is a primary one. The fourth one is a tertiary one. We can cancel it. Secondary alcohol on oxidation, we will get ketone. Which ketone is this? Butan 2-on. If you want to get butan 2-on, what should be the alcohol? Butan 2-ol. Right? Butan 2-ol. So, third one is the correct answer. So, what is butan 2-ol? CH3, CHOH, CH2, CH3. What will happen? This alcohol converted into ketone. Okay? So, secondary alcohol on oxidation, ketone. Shall we go to the next one? Isopropyl alcohol and the normal propyl alcohols are which type of isomer? What is isopropyl group? This one. This is isopropyl alcohol. What is normal propyl? Normal. Linear chain. Normal propyl alcohol. Which type of isomer is this? Dear all, with your permission, let me just elaborate. Just let me write the isopropyl alcohol in another way. CH3, CHOH, CH3. Possible? Both are same, right? This is called the propan 2-ol. This is called the propan 1-ol. What is the difference? The alcohol position is different. So, which belongs to which type of isomerism? Position isomerism. Propan 1-ol may be prepared by the reaction of propene with which one? So, propene is the starting material. We want to prepare what? Propan 1-ol. Okay, propan 1-ol. Let us prepare. How to prepare? How to prepare? The same question we discussed in part 1. Methanoic acid, H3BO3, sulfuric acid, not dear student. Option third one. What is the reaction called? Only one example given in textbook. Propene you can convert it into propanol by hydroboration oxidation. What is hydroboration? First we are adding diborane B2H6. Second we are doing oxidation by hydrogen peroxide and water. Right? Hydroboration oxidation. Only one example given in textbook. Propene we can convert it into propanol. Option third one is the correct answer. So dear all, we discussed around 100 MCQ, the most important MCQ for the chapter alcohol, phenols and ether, as a part 1 and part 2 video. Hope you clear the concept. If you have any doubt in this one, you can call the Brilliant faculties. We will be here to help you for the term 1 examination and term 2 examination, and for the entire examination, whatever need, JEE, IIT, whatever. So whatever the doubts you have, please contact us. Please keep on practicing NCERT line by line reading and the questions which we discussed here. Okay, so wish you all the best, and we will meet again with some other chapter 100 MCQ. Thank you.